Today we're going to take volumes of revolution one step forward. So remember last time we talked about the general formula or the general rule for volumes of revolution, and it's pi times the integral of the function squared. Now imagine I have two functions. I always have a function that is on top, and I always have a function that is on the bottom. Now, if I rotate those two functions around or about the x-axis, I get what looks like a donut shape. This shape is known as a torus, not the astrological sign, but the mathematical shape. So now when I want to calculate the volume between the two functions, I have pi times the integral of the top function squared minus the bottom function squared. Okay, let's try our first question. So I want to find the volume that's generated by revolving the region between the parabola and the square root function. So the first thing I'm going to do is I'm going to draw it. I'd like you to take a moment to do the same. I actually would like you to double the scale so that's a little bit bigger and you can see it. So you'll see here that I drew my parabola in blue and I drew my square root function in red. And now the area that I'm looking for is this that I've highlighted here in yellow. Notice that my square root function, according to my diagram, is actually the top function, and my bottom function is actually the x squared, or the parabola. So how should I write this? Well, the volume is equal to pi times the integral of the top function, which is root x squared, minus the bottom function, which is x squared, all squared, dx. Now, you'll notice really quickly that I don't actually have anything on the integral symbol. So I don't have anything here and here. Now, if I look at my diagram, where do they intersect? Well, they intersect at 0 and they intersect at 1. So the integral is from 0 to 1. So that's how I figure it out if my diagram is an amazing diagram. But what if you are not a great drawer and you don't know how to do that? So option number 2 is to set the two functions equal to one another. So root x is equal to x squared. And now I want to find what I'm looking for. So I'm going to square both sides. So x is equal to x to the 4. And then x to the 4 minus x is equal to 0. I'm going to take out a common factor of x. And here I get x is equal to 0. And here I get x is equal to 1. So even if I can't draw and my drawing is really shoddy, then I am able to solve algebraically. Okay, so let's simplify a little bit here. The volume is equal to pi 0 to 1 of the integral. Root x times itself is just x minus x to the 4 and then dx. Now, I could do this by hand, which I'm going to do right now, but I'm also going to show you how to do it in the calculator. So here's our option number 1. So if I go to my calculator, I've punched in the two functions, and I've punched in from 0 to 1. And I'm going to hit enter. And it gives me an answer of 3 over 10. So let's try it again. So menu, calculus, I have integral, you might have numerical integral. I'm going to go from 0 to 1. And this time I'm going to actually expand, so it's a little bit easier. So it's going to be x minus x to the 4 of dx. And you'll notice I get the same answer. So regardless of the way that I punch in the function, so if I punched in the function the way that it was written, I get 3 over 10. And if I simplify and put that in, I will also get 3 over 10. Okay, so I know the answer is 3 over 10 by my calculator. Take a moment, everybody integrate, substitute, and see if you get 3 over 10 as an answer. Notice that my answer, when I do the calculation and I take the integral, sub in the numbers, I get 3 over 10. Now, here's the thing you need to remember. Because we didn't sub in pi into the calculator, remember that it's still here in my answer. Okay, so don't forget the pi, and notice I've written units cubed. Awesome, let's try another one. So, find the volume of the solid formed by revolving the region enclosed by the curve, root 25 minus x squared, and the line g of x equals 3 about the x-axis. All right, so first you need to figure out what is 25 minus x squared square rooted, and where is that going to be? So again, I'm going to ask you to double your scale so it's a little bit better, and I'd like you to take an opportunity to draw that right now. Okay, so if you remember, 25 minus x squared square rooted is the top half of a circle with a radius of 5. So I've drawn that here in blue. And g of x equals 3 is a line, a horizontal line, just at 3. Now, the shape that I'm looking for, that I'm revolving, is actually this sort of semicircle shape right here. It's not perfect, but it kind of looks like that. But again, I need to know which is my top function and my bottom function. So looking at my diagram here, the top function is the circle or the half circle, and my bottom function is my line. The next thing I need to know is I need to figure out where they intersect. Now, let's say your drawing again isn't up to par. How would I do this? Algebraically, I set the two equal to one another. So the square root of 25 minus x squared is equal to 3. I'm going to square both sides. So 25 minus x squared is 9. That means x squared is 25 minus 9. 25 minus 9 is 16. So x is equal to plus or minus 4. And according to my diagram, that's pretty good. If yours wasn't to scale, you probably wouldn't have gotten that, but that's okay. Allowing us to do it algebraically is another way that we know that we can do this well. Now, if you remember anything about this, we could take the integral from -4 to 4, or we could find the integral from 0 to 4 and then double that because it's the same on the other side. So I think I'm going to do that. I feel that's a little bit better for me. So here, the volume is equal to pi, and I'm going to put the 2 in, so it's going to be 2 pi. The integral from 0 to 4. The top function is the root of 25 minus x squared, all squared, minus the bottom function, which is just 3 squared, dx. All right, so I'm going to simplify a little bit here. When I simplify, I get 2 pi from 0 to 4 of 25 minus x squared minus 9 dx. Well, I can simplify a little bit further. 2 pi from 0 to 4 of 16 minus x squared dx. Okay, so right now you can go to your calculator. We're going to do it both ways. We're going to finish this by hand, and we're going to check our calculator. Again, if you want to do it in the calculator, you can enter it from this stage here, or you can enter it from this stage here. It's up to you, whatever you prefer and whatever you're most comfortable with. So everybody give that a try. Finish integrating by hand and double check your answer in the calculator. I'm going to do the same. Okay, so I integrated by hand. I got the integral of 16x minus a third x cubed applied from 4 to 0. I sub in the 4 and I sub in the 0. I get out 256 pi over 3 because I expanded everything. Now, if I go to my calculator, in my calculator, I did 2 times the integral from 0 to 4 of 16 minus x squared dx. Notice I got 256 over 3. I just have to add the pi in, and you'll notice that my answers are the exact same. Okay, I think it's really time for you to do some practice. Please make sure that you do the practice so that this comes very easily to you as you go through it. Try some questions by hand and some questions with a calculator, or do all the questions by hand and then verify your answers with the calculator. That way you're getting practice for both paper 1 and paper 2. Thanks, guys.